All right, here, a student has a solution of ammonia of unknown concentration. He would like to solve and determine the concentration of this solution, so he decides that he's going to react it with hydrochloric acid and do a titration reaction. So he takes 10 milliliters of the ammonia and titrates it with 0.450 molar hydrochloric acid. He produces this titration curve that we see down here, and he can use this data to determine the concentration of that ammonia solution. But let's just clarify a few things, what we are doing here. Our unknown concentration is the ammonia. Okay, we call that the analyte. That is the solution that we are analyzing. This one goes into the flask of our titration setup. And then we have the hydrochloric acid that we do know the concentration of, and this is called our titrant, and this is the solution that goes into the burette. And what we're doing in titration is we are figuring out how much of that titrant, what volume of that titrant is needed to completely react with all the analyte in the flask. So looking at our titration curve, there's one part of this curve that you need to concern yourself with right now, and it's the vertical section of this graph. It is the part where the pH changes dramatically, and this is a key aspect of the acid-base titration curve. We're looking for this vertical line. Okay, that vertical line is going to contain the point called the equivalence point. That is where the acid and base have completely reacted with each other. You have added just enough titrant to completely react with all the analyte that was present. In other words, they're present in stoichiometric ratios with one another. And so that is your equivalence point, and you want to read the volume needed to reach the equivalence point. And for us, it is 90 milliliters of HCl that would be required to reach the equivalence point. So this is the key information from the graph. Using the 90 milliliters of hydrochloric acid along with its molarity, we got volume, we got molarity, we can multiply those and get the moles of hydrochloric acid needed to complete this reaction. Okay, so I have taken our 90 milliliters of hydrochloric acid, converted over to liters, and now I'm using its molarity of 0.450 molar in dimensional analysis to convert to moles of our hydrochloric acid. Essentially, liters times molarity gives us moles. Now, those are the number of moles of hydrochloric acid needed to completely react with all of the ammonia. So now that I know how many moles of HCl reacted, I can use that with stoichiometry to figure out how many moles of ammonia reacted. So you got to look back at your balance equation for those coefficients. It is a 1-to-1 ratio of acid to base, and we're going to throw that into our dimensional analysis. We see here from our balance equation, for every 1 mole of ammonia that reacts, 1 mole of hydrochloric acid reacts. So it's a 1-to-1 ratio. So I'm going to use this setup to solve for moles of ammonia that reacted, which would be the moles of ammonia in the flask. All right, we determined that 0.0405 moles of ammonia were present in the solution that we put into the flask. And one last thing that they want us to do here, the big question is, what's the concentration of the original ammonia that we put into the flask? So let's start by writing our molarity equation out. All right, here's my molarity equation. They're asking me to solve for the original ammonia concentration that we put into the flask. So I am being very intentional with my words here. I am writing the word initial because that's going to help me choose the right numbers to plug into this equation. I want to take the initial moles of ammonia and divide it by the initial volumes of ammonia that we placed into the flask. We solved from our stoichiometry that there were 0.0405 moles of ammonia initially in the solution in the flask, And the problem told me that we placed 10 milliliters of that solution in the flask. So I converted that over to liters, so we get 0.010 liters. So I divide these two numbers and I will have the molar concentration of the original ammonia solution. So the ammonia that we originally put into that flask had a molarity of 4.05 moles per liter. You can write a capital M instead of moles over liters if you prefer. We would say 4.05 molar ammonia solution.